So let us discuss about the efficiency of a bridge rectifier. The efficiency is notated by the letter eta, that is given by PDC divided by PAC. P is the power, DC power output divided by AC power input. So this is the efficiency. So PDC is equal to IDC square into RL. We know that IDC is equal to 2IM divided by pi. So IDC square is equal to 2IM divided by the whole square into RL. So that is equal to 4IM square divided by pi square into RL. So PAC is equal to IRMS square. Is the AC input power into 2R plus RL, where RL is the load resistance and small r is the resistance of the diode. We know that during the positive half cycle, two diodes are in series, and also in the negative half cycles, two diode also is in series. So the total resistance of the circuit is 2R plus RL. So that is given by, when you substitute for IM, you will get by IRMS. When you substitute for IRMS, you will get IRMS equal to IM divided by square root of 2. So IRMS square is equal to IM divided by square root of 2 the whole square into 2R plus RL. So when we apply it for the efficiency formula of a full wave bridge rectifier or full wave, so PDC is equal to 4IM square RL divided by pi square. PAC is equal to IM square divided by 2 by 2R plus RL. So this IM and IM get cancelled. So that is equal to 4 into 2, 8 divided by pi square into RL divided by 2R plus RL. And that is 8 by pi square is equal to 0.81 RL divided by 2R plus RL. So when this small r is very small, when we compare with the load resistance, you will get the expression for eta as 0.81, that is 81%. So the efficiency of the bridge rectifier is 81%. So let us discuss about the filter circuit. So a rectifier circuit is used to convert AC into DC. But we know that the output of this rectifier is always a pulsating one, whether it is a half wave rectifier or a full wave rectifier, even for a bridge rectifier. So we use this filter circuit to remove the AC component from the output. So using filter circuit, AC is filtered out, and in the output there is only DC component. So the filter circuit is used for the filtration of AC. So AC is filtered and out, and the output containing DC only. So normally filter circuit are either a capacitor or an inductor or its combination. So why these capacitors and inductors are used as a filter circuit? Now let us examine the resistance offered by the capacitor. Normally we call that as an so there is a mistake here. The resistance offered by not a capacitor it is an inductor. So there is a correction. This is not a capacitor, this is an inductor. The resistance offered by the inductor is given by inductive reactance. So inductive reactance we already studied. You already studied in your plus 2 classes that the inductive reactance XL is equal to L omega, where L is the inductance and omega is the frequency 2 pi nu. Omega is nothing but 2 pi nu, angular frequency. Okay, so for DC we know that omega, there is no fluctuations or frequency for DC current, so omega is equal to 0 for DC. So what about XL? XL is equal to 0. That means it is, what is inductive reactance? It is some sort of resistance offered by the inductance to the flow of current. So XL 0 for DC means the inductor will offer no resistance, or that is in the case of an inductor. Then what about capacitor? In the case of a capacitor, we call this resistance offered by the capacitor as a capacitive reactance. Normally it is notated by the letter Xc, capacitive reactance. So Xc is equal to 1 by C omega. This 1 by C omega is the resistance offered by the capacitor to the flow of current. Okay. For DC, what is omega? We know that for DC, omega is equal to 0. So what is the resistance offered by this capacitor for the flow of DC? That is equal to 1 by 0. That is equal to infinity. So the capacitor offers infinite resistance to DC. Inductor offers no resistance to DC. So this is a diagram of a capacitor filter. So here is the AC input. This is a rectifier circuit. It may be an AC or it may be a bridge rectifier and any rectifier. So we are given capacitor as a filter here. The capacitor is always connected parallel to the load resistance. Normally capacitor is connected parallel to the load resistance for doing the filter operations. During the filter operations, the capacitor is always in parallel. What is parallel means? This and so this is a circuit. Here this is the rectifier. V2 is the output of the rectifier, and VC this is RL and this is capacitor. So the voltage across the capacitor is VC, that is equal to the voltage across the resistance because they are in parallel. In the parallel, if two components are parallel, the voltage across them is same. So the voltage across the capacitor is same as the voltage across the resistance. So the capacitor, there is a property for the capacitor, it will charge when V2 is greater than VC. So the capacitor charged till the V2 is greater than VC. If suppose this is the V2 voltage, suppose this is V2 voltage, that is the peak voltage. There is another just below that there is a line which is known as the VC, voltage across the capacitors. So the capacitor is charged up to V2 is greater than VC. So when it is reached below this point, from this point to here, VC is greater than V2. During this peak, here V2 is greater than VC because VC is some point here, line here, that is the voltage across the VC. So when this is the charging point, when it reaches here, it will start discharging because at this point V2 is decreasing. So this here, from here point onwards, VC is greater than V2. So the capacitor discharges like this. So at this point, we know that this is increasing point. From this point onwards, V2 is greater than VC. So the capacitor will charge till this, and when VC is greater than V2, it will discharge till this point. Then this will repeat. So this will be the output waveform of a capacitor filter circuit. For otherwise we can explain as, so there will be AC and DC component in the V2. So when it reach here, the current will flow here and here. So this is a capacitor. When it reached here, it will block all the DC. So the capacitor will not allow DC to pass through the capacitor. And AC is bypassed through the capacitor. So AC is passed through this but DC cannot pass through the capacitor, so DC reached here, so through RL we get DC current through RL. AC current is bypassed or filtered by the capacitor. So when the current having AC and DC component reached here, AC passed through it or bypassed through it, and DC passed through the resistance. So that is the simple working of a capacitor. One point is important here. This capacitor is always connected parallel to the load resistance. Then only AC filtered through this and DC passed through this. Okay. So here inductor is used as a filter circuit. So this is the rectifier and this is the rectifier output. So when the current reached here, this inductor offers some inductive reactance to AC. So it blocks some AC, but it offers zero resistance to DC. So DC can easily pass through it. Some AC is blocked here because it offers some inductive reactance to the AC. So the DC component, all the DC component, because the inductor offers zero resistance to the DC, so all the DC current pass through this. So we will get more DC in the output. So this inductor is used as a filter circuit. But here inductor is always connected in series with the load resistance. So another filter circuit is a pi circuit. Here there is a capacitor and there is an inductor here and also capacitor here. So let us examine its working. So the output from the rectifier reached here. When it have AC and both AC and DC component, first the C1, the bypass capacitor, passes AC and block DC. So all the DC part reached here. Here there is an inductor. Inductor offer high resistance to AC. So there is also some restriction to AC to pass through it, but it offers zero resistance to DC. So the current passed through this. And when reached here, what happened? Here also, if the any AC component, it will bypass through the through this, and all the DC passes through the load. So the load, all the AC component is filtered out by the pi circuit. It is just like pi. So the letter pi. So this is called the pi circuit. So the output containing more DC component. So this will be the output of the pi filter.